All right. Mr. Richard's friend Shirley called him, and she makes pendants. She starts with 10 centimeter length of wire and cuts it into two pieces. And then she forms two geometric shapes. Suppose one piece is bent into the perimeter of a square pendant. There's my square pendant. And one piece into the perimeter of an equilateral triangle. How should she cut the wire? Here's our wire. 10 centimeters. How should she cut the wire in order to minimize the combined area of the two pendants? That's kind of a weird thing to do, minimize the combined area. So we got to make a cut here. So if I make my cut here, and I call this side x, I'm going to call this side 10 minus x. That's our first setup, I think. So I've got a square, and it has sides of S, and the pendant in the other into the perimeter of an equilateral triangle pendant. So I guess we'll go T, T, T. So I think right there we can come up with a couple of equations. The perimeter of the square is 4s, and that's going to be equal to my x. Does that make sense? And then right here, this perimeter, 3t, is going to be equal to my 10 minus x. So there's my perimeters and my wire, I guess. So 4s plus 3t equals 10. That makes sense. Now we want to minimize the combined area. So we need to come up with an area equation. That's probably going to be our optimization one. Area equals, area of a square is s squared. The area of an equilateral triangle, we can show that proof, but the area of an equilateral triangle is side squared root 3 over 4. So we're actually kind of close there. If I use this equation right here, I can solve probably for one of my sides. It might be easiest to solve for s and plug it in here. So let's go ahead and do that. S equals 10 minus 3t over 4. So now I can put this in here, solve, and then I've only got my one variable. So area equals 10 minus 3t over 4 squared plus t squared root 3 over 4. And really, this isn't that bad of a problem, I don't think. If I do a little bit of simplification, I've kind of only got to use the power rule, really. So I'm going to do that right here. I'm going to square everything. I'm actually going to square that 4 on the bottom and call it a 16th and put that in front. And then inside I've got 100 minus 60t plus 9t squared plus that root 3 over 4 is really just a coefficient of the t squared. So that is my area. Now, probably a good move would be factor out that over 16 from the whole thing now. And then I'll have some clean numbers to work with. I guess I really don't have to. I could actually just derive from here. So if this is my area equation, we can go ahead and do the derivative. My derivative right here, this 1/16 can actually just kind of stay in front. So then my derivative of the inside is negative 60 plus 18t plus 2 times root 3 over 4 is going to be root 3 over 2t. We're going to set that equal to 0 and start solving. So if we solve that, we get t equals 1.88. That's just a line. If I put that in my calculator, I think it looks like this. So what does that represent? That represents the side of, in this case, I had t was my sides of the triangle. So t was the size of the triangle. So let's ask, how should she cut the wire in order to minimize the combined area? So she should cut the wire where? 3 times. So she should cut the wire at 3 times 1.88 would be 5.64. That's where she should cut the wire at. I like it. And then make her square and her triangle. Now try the next one.